Welcome to 7.3. Still dealing with parallelograms, but we're going to go the opposite direction. If you have all four sides being congruent to opposite sides, then you have a parallelogram. So that's the parallelogram opposite sides converse theorem. And if you have opposite angles being congruent, that's the parallelogram opposite angles converse theorem. Now, here's something new. Opposite sides parallel and congruent. If you have one pair of sides that are parallel and they're congruent, then you know those two are parallel congruent as well. And at the bottom, if your diagonals bisect each other, then you know you have a parallelogram. Okay, let's go on. And here's a quick way to show, prove that you have a parallelogram. Again, if you have opposite sides are parallel, if you have opposite sides are congruent, opposite angles are congruent, opposite sides are parallel and congruent, just one pair, and the bisectors. So the exact same thing we just got done talking about. Okay, state which theorem you can use to show that a quadrilateral is a parallelogram. All right, well, we have opposite angles are congruent and opposite angles are congruent. So that would be your opposite angles converse theorem. So parallelogram, opposite angles converse theorem. And then on this side, on number 2, we have opposite sides. So parallelogram, opposite sides converse theorem. Number 3, you have diagonals that are bisecting each other. So parallelogram, diagonals, converse theorem. So parallelogram, diagonals, converse theorem. And again, opposite angles. So parallelogram, opposite angles, converse theorem. Number 9, you have opposite side. One pair of opposite sides are congruent, and they're the same ones are parallel. So that's important that you have the same ones. So you have to have both of those. So parallelogram, opposite sides, and parallel theorem. And congruent. Parallel and congruent, I guess we should say that. Congruent, to be exact. And then this one, diagonals bisect each other. So parallelogram, diagonals, converse theorem. So find the values of x and y. So if these are parallelograms, then that means opposite angles are equal. So x is 114. And that means y has to be 66. And on number 8, if there is a parallelogram, then y is the same as 9, and x is the same as 16. Very simple. All right, so now, same type of thing, but you have to set these equal to each other. So 4x plus 6 has to be equal to the opposite side. So we solve. I'm going to take 4x to the right, and 6 equals 3x minus 3. And I'm going to add the 3 to the left, and then I'll divide off the 3. So x equals 3. But what about y? You got to set those equal to each other. So we have 4y minus 3 equals 3y plus 1. Let's break this page apart here. All right, so let's subtract 3y. And y minus 3 equals 1. And so we add 3. Y equals 4. And on number 10, we have angles. So these two are equal, but notice you have an x and a y. So we can't figure that out yet. What about the other ones? Yeah, these are just x's here. So we're going to have to solve that one first. So 4x plus 13 is equal to 5x minus 12. I'm going to subtract 4x. 13 equals x minus 12. Add 12. And 25 is what x equals. Now we can set up the first one, this one right here. So 3x minus 8 is equal to 4y plus 7. And we know what x is. We just solved it. So 3 times 25 minus 8 is equal to 4y plus 7. 3 times 25, or 3/4, is 75. And 75 minus 8 is 67. So we subtract 7. And that gives us 60 equals 4y. Divide off the 4, and y equals 15. So y is 15 and x is 25. Same type of thing here, except you have a different theorem that you're dealing with. So the diagonals bisect each other to make this a parallelogram, which means those two have to be equal. So 4x plus 2 has to be equal to 5x minus 6. Okay, so subtract 4x. You could subtract 5x to the left if you wanted to. So 8 is x. All right, and again, parallel and congruent theorem. Subtract x, and we get 1x plus 3 equals 7. Subtract 3, x equals 4. Same thing. These have to be congruent, so 3x plus 5 has to equal 5x minus 9. I'll subtract 3x to the right. The reason I'm going to the right is because I know I'll get a positive 2x. That's how I know which direction I go. I won't always get a negative. The next one, I'll go the opposite direction. All right, so now we add 9. So 14 equals 2x, and divide off the 2, x is equal to 7. Over here, it's actually set up correctly. The diagonals bisect each other, so these have to be equal. So 6x equals 3x plus 2. I must subtract 3x to the left, and that's 3x equals 2. Divide off the 3, and we have a fraction. That's okay. All right, so now you have to graph these things, and looks like they're all positive, and we have a 12 and an 8 for x. So I'm going to make this large in the first quadrant here. All right, so A is 0, 1. We'll go by fourths there. So that's 0, 1. And B is 4, 4. 1, 2, 3, 4. 1, 2, 4. There's B. C is at 12, 4. So 4, 5, 6, 7, 8, which we'll need in a minute. 9, 10, 11, 12. So 12, 4. 1, 2, 3, 4. That's C. So A to B, B to C. That's horizontal. That's a good thing. And D is 8, 1 right there. So now, what's it asking? Graph the quadrilateral with the given vertices in a coordinate plane. Then show that the quadrilateral is a parallelogram. Okay, well, you can use any of the parallelogram theorems. So I'm going to use the easy one. I know, I'm going to change this to yellow. I know that BC is horizontal and AD is horizontal, so they have the same slope. I could do the slope of A to B if I wanted and D to C, but I can also count horizontal lines. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units long. What about B to C? 1, 2, 3, 4, 5, 6, 7, 8. So there, I just proved that their slopes are the same and they have the same length. Sometimes you have to use the distance formula, but not on horizontal or vertical lines. So I used parallelogram opposite sides are parallel and congruent. That theorem. All right, so let's graph this. So I'm just looking at my values here to see how big my graph can be. Okay, so the biggest number is a 5 or -5 or whatever. So I'm just going to put it right in the middle and use the go by fourths again on the grid. So -3, 0, 1, 2, 3 is E. F is at -3, 4. 1, 2, 3, 4. So -3 up 4. G is at 3, -1. 1, 2, 3, -1. And H is at 3, -5. So 3, 1, 2, 3, 4, 5. So here we have vertical lines. This makes it easy again. So we graphed it. That's part of it. You do have to graph. All right, so how do I prove them? I'm going to, again, do the exact same thing I just got done doing. Because I can count 1, 2, 3, 4. And I know a vertical line has an undefined slope. And G to H is 1, 2, 3, 4. So again, it's the exact same thing as the last one. Parallel and congruent. All right, so same slope and congruent. Okay, JKLM, let's look at these numbers. And we have 2 and a 3, 5 and a 7, and we have 6s. Okay, same type of graph. Just makes it easier so I don't have to do anything else. Okay, I'll just do this in blue. J is at negative 2, 3. 1, 2, 1, 2, 3. That's J. K is at negative 5, 7. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. L is at 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. M is at 6, 2. 3, 4, 5, 6. 1, 2. So JK, got to connect them in order. J to K. K to L. Notice they're not vertical or horizontal, so now we're going to have to do some work. All right. So now you get to pick and choose what you want to do. I would just do use parallelogram theorem about opposite sides being parallel. So by definition of a parallelogram, opposite sides are parallel. You have to have both pairs. So let's do the slope of JK. So the slope of JK, and we're going to do rise over run. From J to K, I go up 1, 2, 3, 4. So that's a positive 4 going up, but I go left 1, 2, 3. That's negative. All right, now we got to do the slope of ML or LM. So from L to M, I go down 1, 2, 3, 4. So that's negative 4, and over 1, 2, 3. So I know that those two are parallel based on their slopes, but you have to have the other side as well. So in a picture, we would put these little slope or parallel markings on that. So now you have to do the others. The slope from K to L, I go down 1, and then 1, 2, 3, 4, 5, 6, 7, 8. So down 1 and over 8. And the slope from J to M, down 1 and over 1, 2, 3, 4, 5, 6, 7, 8. And they have the same slope. So those two would be the next pair of parallel lines. And since we have opposite sides being parallel, by the definition of a parallelogram, opposite sides, both pairs of opposite sides are parallel. All right, last one. Let's see, 5. These are a normal graph too, so negative 5, 0. 1, 2, 3, 4, 5 is N. 0, 4. 1, 2, 3, 4 is P. 3, 0. 1, 2, 3 is Q. And R is at negative 2. 1, 2. And negative 4. 1, 2, 3, 4. All right, so now the question is, prove these, not question, you have to prove these are parallel. So I'm going to do the same thing again because rise over run is easy to do. A lot of times they'd like you to do a distance formula, which you're all supposed to know how to do. So let's just do the slope. So let's do the slope from N to P. Okay, so 1, 2, 3, 4. Up 4 is positive, and to the right, 1, 2, 3, 4, 5 is positive. Now we'll do RQ. Up 1, 2, 3, 4, and over 1, 2, 3, 4, 5. All right, so those are parallel. So we could just do a little triangle on there, and those are parallel. Now we do the slope of N to R. So I'm going to go down 1, 2, 3, 4. That's negative. I'm going to go over 1, 2, 3. And that should match from P to Q. So down 1, 2, 3, 4. And over 1, 2, 3. And it does. So their slopes match. So by definition, it's a parallelogram. All right, describe and correct the error in identifying the parallelogram. Okay, obviously it's not a parallelogram. It says by the opposite sides converse theorem. So number 1, not a parallelogram. Okay, it's a kite by definition, but we haven't covered that yet. So to correct it, number 1, it's not a parallelogram. That's the correction. What they did wrong was assume opposite sides. Number 20, they assumed opposite sides are congruent and they're parallel. Well, that's definitely congruent, but there's nothing to say that it's parallel. So not enough information. They may be parallel. It may be a parallelogram, but there's not enough information to prove it. And that is the end of your homework.